Hello, this video is a part of Chapter 2 Atomic Structure of the Class 11th NCERT textbook. I will be discussing about the emission spectrum experiments which formed the basis for formulation of Bohr's model in early 20th century. I have made two videos to explain this. In the first video, I have discussed on how the experiment is conducted, and in the second video I have talked about deriving some results or the consequences of this experiment and how these consequences led to the development of Bohr's model. So the experiment is basically observing the spectrum of emitted light through a gas when the gas is sparked in a discharge tube, and you will observe that gas glows when we do so. Now, you would have learned in your ninth standard that Rutherford, after his famous gold foil experiment, arrived at a model which stated that the nucleus is confined in a very small region of the atom and electrons revolve around that nucleus. But it was forbidden by the classical theory of electromagnetism, since in that case the electron will continuously emit radiation, or we can say it will continuously lose energy and will move spirally, and ultimately it will fall into the nucleus. So here you can see in this diagram there is a positively charged nucleus and a negatively charged electron. If the Rutherford's model would be true, the orbit radius of the electron will reduce continuously, and it will undergo a spiral motion, and will ultimately it will fall into the nucleus. So but we knew that the atoms are stable and this cannot be the case. And one more thing to note here, when this electron will lose energy and will fall into the nucleus, during this time it will emit light, and that light would be of several different colors. If plotted, it will be something like this, a continuous band of spectrum. Okay, so and now we move on to discuss some basic concepts which you must have read in the beginning of the chapter. These concepts are the prerequisite for this experiment, for studying this experiment. So please visit if you haven't visited them before. The first one is theory of radiation. You would have studied it as black body radiation. It stated that every body or the every object at a temperature greater than 0 Kelvin. 0 Kelvin is the absolute lowest temperature of a body. Okay, so it emits energy in the form of electromagnetic radiation, right? So as you can see, there's a infrared camera. A person is holding it and observing a dog. Now you can see in the picture there are some red or blue patches. The red patches indicate higher temperature, more radiation, and the blue patches indicate lower temperature or the lesser amount of radiation. Temperature is less. So, and the second concept, which is a prerequisite, is the Planck's hypothesis. It stated that energy is not emitted continuously. It is not emitted continuously, but it is uh, but in the form of discrete wave packets, which are called as quanta in general. For light, such quanta are known as photons, that we call as photons, right? So this is a mathematical notation of Planck's hypothesis. E is equal to n times h times nu. E is the energy emitted energy of radiation. N is number of photons in that, and H is the Planck constant, nu is the frequency of light. So this is a wave packet. This is how it looks like. Mm. So now, since this hypothesis was believed to be true, the atom could not emit radiation continuously. So it emits in the form of wave packets. So how can we see that? How does an atom actually radiate energy? For this, we move on to the next slide. So in order to see how the electrons are actually arranged we inside the atom, we observe their spectrum, the atomic spectrum. So a general question for you now: if you have an object, okay, if you have a general object which is not glowing, which is not emitting any visible radiation, how would you see its spectrum, the light coming from inside of that thing? How would you see that? So if it is not obvious, I have a hint for you. Rewind the video 1 minute back and go back to the previous slide where I discussed about the radiation theory. Okay, so I hope you visited or would have arrived at the answer. So the answer is change its temperature up to an extent so that emitted radiations become visible and more intense. Now I have shown some pictures or examples. In the first, you can see an iron rod which is heated on a burner. And now you can see that some part of it glows red, and here also you have an iron rod. It is heated using an electrical device basically. Mm, and one thing, this device heats the iron rod much more rapidly than this burner. Okay, so that's for your knowledge. And how would you heat a gas? So a gas can be heated like applying the high voltage across the ends of a tube and concentrating the gas in this tube. There is a cathode, anode, and we apply voltage across them. So we can confine the gas in this tube and it will get heated up. So now we move on to discuss the setup of this experiment. We take a discharge tube and store a gas in it, fill a gas in it, and apply high voltage across the ends. So we have taken a discharge tube, applied high voltage across the ends. The emitted light, this gas will glow and it will emit a light. So this emitted light we pass through a prism and obtain on a screen, obtain the different colors which this light comprised of on a screen, right? So here in the experiment which we are going to demonstrate in the next slide is we do not here we do not take a prism. Instead we take a diffraction paper. It's a diffraction grating, so it basically does the same thing, so don't confuse with that. So next. So now we proceed on to explain the demonstrate the experiment. So first we will observe the spectral lines of this incandescent bulb on a diffraction grating. So you will see how it is similar to the diffraction grating is similar to just a prism, right? So
This diffraction grating in front of a camera and show you the view of this continuous source with the diffraction grating in place. And what you'll see in the image is the image of the incandescent bulb itself, and then to the right and to the left you'll see a rainbow spectrum that shows what wavelengths are present in this. You'll see, as you look on the right side, violet through all the colors of the spectrum all the way through red. So that's a continuous spectrum. We'll try next to look at a discrete spectrum of mercury. Now what this is it's a discharge tube. It has mercury in it, and what I'll do is energize this tube, apply a voltage to the tube, and that causes the gas in it to emit spectral lines according to the spectrum of the element that we're using, in this case mercury. So I'm going to locate this proper spot, turn off the continuous spectrum. So this is a mercury spectrum without the diffraction grating. And we'll get it in focus here. It's a bluish colored spectrum. There are mercury vapor lights that are used as street lights. So this may look similar to this bluish tint to the mercury vapor. Now let's try it with the diffraction grating in place. And what you see in this case are a green line and a blue line predominantly in this mercury spectrum. Next we will try a nitrogen spectrum. I'm using this fur to prevent burning flesh. So this is nitrogen spectrum. And with the diffraction grating in place, we see a number of lines present, some red, orange, yellow, green, and a violet turquoise-ish colored line. That's nitrogen. Two more. This is neon. There's a beautiful orange look to it, and when the diffraction grating is in place, you see a large number of red and orange lines. This is exactly what's used for neon lights. The original neon light was made out of neon like this. There are other gases that are used to form signs, but neon was really where it started off. It has a beautiful, bright, reddish-orange spectrum. So this is hydrogen. It has a reddish cast to it. And when the diffraction grating is in place, you'll see three lines. The farthest from the central image is a red line. That's the hydrogen alpha line. And it is
this was basically the overall experiment. So the conclusion points of this experiment will be explained in the next video. Thanks for watching and see you in the next video.